Hi guys, welcome to the third session of Practical Approach to Java. In this session, we are going to learn some of the basic stuff like variables, data types, typecasting, and so on. Firstly, we need to understand about keywords and identifiers in Java. There are certain reserved words that mean a specific thing to a Java compiler. For example, public, class, static, void, new, return, and so on. These are called as keywords. And notice that Eclipse has a different coloring scheme to represent the keywords. All the other stuff in the code, like variables, constants, and expressions, and so on, they represent the identifiers. So basically, your Java code is a combination of keywords and identifiers. Okay. A variable is nothing but a named memory location of a specific data type. That means if you have a variable, say x, it has a name which is x and also a data type associated with it which is int, which means that I can only store int values in x and I cannot have a decimal value like this, and it would throw a syntax error. So Java is a strongly typed language, which means that we can equate only the same data type. So in Java we have basically four categories of primitive data types, and they are integers, uh, floating point numbers, characters, and boolean. So under integers we have uh, byte, short, int, and long. All these belong to the category of integers and they are of different lengths respectively. Byte is 1 byte long, short is 2, integer is 4 bytes long, long is 8 bytes long. So the length here basically represents the range of values that a byte variable can hold. 1 byte is 8 bits, which means a byte variable can hold a range of minus 127 to plus 127, which is 256, a total of 256 values. Similarly, the short can hold minus 2 to the power 15 to plus 2 to the power 15 values, and so on. Under floating point, you have float and double, which is 8 and 4 bytes long. And under characters, you have a char data type, which is I think 2 bytes long. I'm not sure about that. And boolean basically is a data type which is used in condition checks. So it has only two values, true and false. Notice that all of these are color coded, so they all are keywords in Java. Okay. Uh, One interesting thing about the order of these data types is that, especially in integers, the lower order data types like byte and short are implicitly converted to int when they are used in expressions. For example, if we have a byte b is equal to 10, when we use b in an expression like this, b is equal to b plus 1. Here, b in this expression, b is implicitly getting converted to int. Since the result of int plus int gives an int, we cannot equate that to a type of byte. So there are two ways of solving this problem. One is to equate it to a type int I is equal to another int, which is basically what it's doing is it's doing a type promotion. So b being a byte is getting promoted to a higher order integer int, and it's getting equated to I. Such kind of conversions are called as implicit conversions. And whenever an implicit conversion happens, it's always to a higher data order. Another way of handling the same problem is by explicitly using a cast. For example, byte in this case. So we are converting b plus 1 to a byte before we assigning back to b, which is of data type byte. By explicitly using a cast, there is a danger of losing some of the values. In this case, maybe we are not losing anything, but since the value of b plus 1 is an integer and we are converting it to a lower order data type, there is a danger of losing some the additional bits. So unless we are absolutely sure that we won't be losing any data, explicit typecasting is not encouraged. The same holds for float and double too. If we have a float variable f and we are assigning a constant 2.5, here 2.5 is implicitly converted to double even during declaration. So the way to solve the syntax error is to add a cast to a float or define f as a double. So this is a very important thing that we need to know about lower order data types. Okay, moving on. If you notice, we have curly braces here and here. They're opening and closing. So what this represents here is a block of scope of all the variables and methods within curly braces are local only to this block. That means if I define a variable within this method, I will not be able to access it outside of this method. Similarly, this represents a class scope. So whatever methods and variables I use in test will be accessible only within test and not outside. So within the method also you can have a block of scope when we are using loops and conditional statement. For example, if we have a if statement and a block of code like this, and we declare int y is equal to 9. What this is saying is the variable y is local to this block and it's not accessible outside of this. So if I try to do y plus plus, it gives me a syntax error saying y is not a local variable. However, the variable x here, being an outer variable to this inner block, can be accessed within this block because the scope of x is within this. Sorry about this. The scope of x is within this block, so which includes the inner block. So x can be accessed within this block, but y cannot be accessed outside of this. So that was about the variables and typecasting. That's all for this session. Thanks for watching.